everyone. We're going to move on to the next part with polynomials, which is multiplying polynomials. Now, we already talked about how we multiply monomials, so single term polynomials. If you remember, the way we do it is we are going to first multiply the coefficients, and then we end up adding the exponents that have common bases. So for example, if we had this 5x squared times 3x cubed, what we're going to end up doing is taking the 5 and the 3, multiplying them together, and then taking the x squared and the x cubed and multiplying them together. The 5 and the 3, their coefficients, they multiply like normal. And then with the exponents get added together. So it's 2 plus 3, which gives me 15x to the fifth. So we're going to end up doing that same thing, but now when we start talking about polynomials, we're going to end up having multiple terms. So what we're going to end up doing is what we call distributing each term. So we're going to end up taking monomial by monomial and distribute across each thing so that every single term gets multiplied with each other. So here's an example. So this is a binomial. It has two terms. So we're taking a binomial and multiplying it by a binomial. So the first part, I'm going to take the x and I'm going to distribute across to the two terms on this side. So x times x plus x times 7. Then afterwards, I'm going to take this term, the 8, and distribute to the two terms again. So 8 times x again, and then 8 times 7. And that's it. So this is the distributing that we're referring to. So like I said, take the x times x right here, x times 7 over here, 8 times x written right here, and then 8 times 7 over here. So combining this together, well, these both have an exponent of 1. So again, we're going to add their exponents. These just get left as being multiplied together because there's no common base. And then these are coefficients, or constants in this case, and we're just going to multiply them normally. So we end up getting this. The 7x and 8x have a common variable, so I can actually add them together, and this becomes x squared plus 15x plus 56. So when you actually have two binomials like this, there's a certain method that you might hear some other people say. It's called the FOIL method. It stands for first, outside, inside, and then the last. Basically, what you're saying is you're going to multiply the first terms in both of these binomials, multiply the outside terms in the polynomial, take the inner terms, multiply them, and then the last terms in both polynomials. So sometimes it can help, but it only really works for binomials. All right. So here's the first two questions. Pause video, work itself, and we'll go over in a second. All right. So once again, we're going to take this. Now we have a monomial multiplied by a binomial, so we don't have to worry about that whole FOIL thing that I said, but we are still going to distribute. So we're going to distribute this term to this one, and then this term to that one. So 2a distributed to negative 2, well, that gets me 2 times 2a, and then 2a distributed to the 3a gets me 2a times 3a. Here there's no variable, so I'm just multiplying the coefficients. Negative 2 times 2 is negative 4, and the a stays the same. And then for here, now I'm going to multiply the coefficients, so 2 times 3 is 6, and then I'm going to add the exponents. So 1 plus 1 gives me squared. Normally you want to rewrite in standard form, so I'm just going to flip them so that I have the a squared first. So this is my answer. All right, number 2. So again, I'm going to do the same thing. Take this and distribute to the two terms. So when I distribute to the first term, negative x squared times x, and then negative x squared times 5x. So this negative is going to stay the same since there's no other negative that's being multiplied here. And once again, I'm going to add the exponents. So 2 plus 1 gets me x to the third. And then over here, so again, I'm going to multiply the coefficient. So here it's a negative 1, and this is 5. So this becomes negative 5. And once again, add the exponents. 2 plus 1 gets me x cubed. And I can actually take it one step further and combine these to be negative 6x cubed. Since when we add these, remember we just add the coefficients. Negative 1 plus negative 5 is negative 6. Realistically, you also could have done this by combining the x and the 5 first before you distribute. Either way. Alright, so here's the next set of questions. Pause video, work on stuff, and we'll go over in a second. Alright, so again, we have a monomial, this time being multiplied by trinomials. So again, 3 terms, but it's the same thing, just with one extra step. So again, take the 2, distribute to the first term, 2 times n squared. Distribute to the second term, minus 2 times 3n. And then to the last term, plus 2 times 2. So cleaning this up a bit, we get 2n squared. Negative 2 times 3 is negative 6n. And then 2 times 2 is 4. 3 is the same thing. I'm going to take the s cubed, distribute to the first term. So I get s cubed times 2s cubed plus s cubed times the second term, which is s squared, and then s cubed times the last term. So I'm multiplying it by the negative 5. So coefficients are 2 and 1, so multiply those and you get 2. The exponents add, so 3 over here and 3 over here is 6. Plus, this is s cubed times s squared. So again, add the exponents, I get s to the 5th. And then this one, there's no exponents to worry about, so I just tack this coefficient onto the s, and I end up getting negative 5s cubed. So I'm actually going to erase that real quick. There it is. There we go. Oh, erased a little too much. Negative 5s cubed. And this is written in standard form already, so I don't have to do this anymore. Alright. Next set of 2. Pause video, work on stuff. We'll go over in a second. Okay, so we're back at having a binomial. So we have, we're going to do our first terms. So x times the first x. Then we're going to do x times the outside term. So x times negative 2. Then we do the inside terms, 3 times x. And then the outside terms, 3 times negative 2. So cleaning this up, x times x gives me x squared. This gets me negative 2x plus 3x. And once again, I made the mistake of accidentally adding minus 6. Combining the 3x and the 2x. I get this as my answer. And then for here, so now I have a binomial and a trinomial. Once again, it's the same thing, just a little bit longer. So x to the x squared, x to the x, x to the negative 1, and then I'm going to use distribute the second term, plus minus 1 x squared, next one, and the next one. So cleaning this up, 1 plus 2 is 3. 1 plus 1 is 2. I am constantly forgetting about the negative. So this becomes minus x. Negative 1 times x squared is minus x squared. I have another minus x. And negative 1 times negative 1 gets me plus 1. So cleaning up, I end up having a minus x squared here and a plus x squared here. So these are going to cancel out. And then I can combine these two terms, negative x and negative x. So I'm left with, I'm going to actually write my answer over here, x cubed minus 2x, because I'm going to combine, I'm going to add their exponent, their coefficients. Negative 1 plus negative 1 is negative 2, plus 1. And this is my answer for this one. Alright, and then the very last question, or the last set of 2 questions. So again, pause video, work and stuff. We'll go over in a second. Alright, so for here, what we're going to end up doing is, once again, distributing, adding in one more term to make it a little bit longer. So I'm going to just write this out. X times x cubed plus x times x squared minus x times x plus x, and then minus 2x cubed minus 2x squared plus 2x, because we have minus x and minus 2, and then minus 2 as my constant. So 3 plus 1 is 4. 2 plus 1 is 3. 1 plus 1 is 2. So minus x squared plus x minus 2x cubed minus 2x squared plus 2x minus 2. So now we're just going to do that whole adding polynomials thing. So combining like terms, we have a plus 1 minus 2. So that gets me minus x cubed, negative x squared, negative 2x squared, minus 3x squared. And combining those two gets me plus 3x. And then my constant doesn't change. Now, number 8, the best, so this time you're not going to do what we learned with the exponents where we had them distribute. That only works, the distributing of the exponent only works when we are actually having only monomials. If we have a binomial, it doesn't work. Instead, we're going to rewrite this as 2x minus 2 times 2x minus 2. Because remember, when you have a binomial raised to a power, anything raised to some power, you're basically saying you're multiplying it that number of times. If this was a cubed, I would add in another times 2x minus 2. So again, going through all the terms, 2x times 2x minus 2x times 2 minus 2 times 2x plus 4, because I know that. So doing this really quickly, this gets me 4x squared. This will get me minus 4x. This gets me another minus 4x. And then this is going to be plus 4. So altogether, I end up getting 4x squared minus 8x plus 4. And that's it. That's all this multiplying with polynomials are. Realistically, the only way to make this a little bit trickier is by, again, giving you longer polynomials to work with. Maybe 2 trinomials or 4 trinomials. So here's the exit question. So Tony has a rectangular garden, has a length of x plus 7 and a width of x squared minus 3x plus 6. I want you to express the area of the garden in standard form. So think about how we would find the area if we had numbers, and then replace that with these expressions. All right, so put your answer here. Now that you're done, if you had any questions, please let me know as soon as possible. You can either ask me in class if you end up seeing me relatively soon, or you can message me through Remind. Good luck and have a great day.